Okay, guys, so moving on to our third lesson, we're going to be looking at basically what amounts to compound interest, but I'll get into that in a little bit. Just quickly, some terms here and formulas as review of simple interest and compound interest. So when an investment earns simple interest, the amount of investment grows according to a linear model. Okay, that is a graphical way of saying that it goes up the same amount every year, right? So remember, for simple interest, interest is only paid on the original amount, so the interest basically stays the same every year. So if your investment was 10 years, you'd pay the same amount of interest in year 1 as you would in year 2, as you would in year 3, as you would in year 8, 9, and 10. Okay? There's a formula which you're familiar with, and here are what each of the variables stand for. At any point, obviously, feel free to pause the video and take a look, but I don't think we need to go over these again in terms of me reading them all over, because they were just in the previous 2 lessons. Okay. Just one thing to remember here, the T for time is in years. So again, if you're ever given the time in a unit that is not years, you need to convert it into years. Okay. And there's our compound interest formula, again, which we just looked at last lesson. If we go up here, what does it say here? When an investment earns compound interest, the amount of investment grows according to an exponential model. Okay, so meaning it goes up the same percentage every year, right? So because here, remember, for compound interest, we pay interest on interest. So if the interest is, I don't know, let's say, for example, 6%, that means every year the amount of the investment or the amount of the loan will go up by 6%. And because it's going up by the same percent every year, we can say that it's going up exponentially or according to an exponential model. Okay, so there's the formula again for you. A is the final amount, P is the principal, I is the interest rate. And remember, per compounding period, so we need to take the interest rate and then divide it by the amount of compounding periods in a year, right? Just like we did in the previous lesson. And N is the number of compounding periods. So again, remember, you take the number of compounding periods in a year and multiply it by the number of years of the investment or the loan, and that gives you your N value. Okay. If there's anything here that didn't make sense, again, like I said, feel free to pause the video and read over it a bit more slowly, or go back to either one of the previous 2 lessons, and there are more examples of each of these in those lessons. And even still, we're going to do a couple more examples here on each of them. Well, one on each of them, one on simple and one on, compound interest. Okay, so number 3 says here, Kazi wants to invest $50,000 in a 90-day term investment. So that means that the investment's going to last for 90 days. That pays, and here's your keyword to tell you which formula you're going to use. It says that pays simple interest, okay, of 3.35% per year. Determine the interest earned and the value of the investment at the end of the term. So to figure out the interest earned, we use our I equals P times R times T formula, and that'll tell us the amount of the interest he has earned. Okay, so P is, P is the principal, or the amount he invests at the start, so we know that's 50,000. R is the interest rate converted to a decimal, so 3.35% converts to 0.0335. And just remember, the trick here is the term, or the time, is 90 days. And for simple interest, we always have to express T in terms of years in order for us to plug it in here and for the formula to work properly. So how many years is 90 days? Well, 90 days is the term of our investment, and there are 365 days in a year. So 90 divided by 365 tells us then that our T value is going to be 0.2466. So 90 days is equivalent to 0.2466 years. Okay, plug that in here and multiply the 3 together. It tells us he earns $413.01 in interest. So that takes care of the part of the question that says interest earned. The second part of the question also asks us the value of the investment. So the value of the investment is simply the principal, whatever you started with, plus whatever interest you earned. Okay, so what's the total value of his investment? Well, he had $50,000 to start with, and then he earned $413.01 in interest. So basically add those two together, and it tells us the total value of his investment is then $50,413.01. Okay, so there's an example of simple interest. So just be careful that you are answering what the question is asking us. If you stopped here, you've only answered that the interest is $413.01. You need to then, because the question asks us to tell what the value of the investment is, we need to do the second part here. Okay, so take the interest, add it to the original amount invested, and there's our total value. Okay. Number 4, Nicole invested $1,200 for 2 years in a mutual fund that paid 3.6% interest per year, with interest compounded monthly. So here is the big word, I guess, that we need to make sure we take note of: compounded, right? So we know that this is going to be compound interest, so we need to use the compound interest formula, which you see right here. Okay. Determine the final amount of Nicole's investment and the total interest she earned on her investment. So again, we're asked 2 things here. So first, we need to figure out the final amount. So the final amount is the A value. So A is what we're solving for. We, from the question, are given P, and we have to calculate I and N. So P is the principal. What does she start with? Well, she invests $1,200. So P is $1,200, nothing to do there. That's strictly or straight from the question. The N value then is the number of compounding periods. So it tells us compounded monthly. So we know monthly means 12 times per year. And that's where that 12 comes from. And how long is the investment for? 2 years, the question tells us. So that's where that 2 comes from. So 2 years for the investment times 12 times per year the interest is compounded. That means N equals 24. And the last little calculation we need to do is for the I value. So the I value is always the interest rate in decimal form. So 3.6% converts to 0.036 and divided by the number of compounding periods in a year. Again, compounded monthly means 12 times a year. So we take the yearly interest rate of 0.036 and then divide it by the number of times the investment is compounded in a year, which is 12. And that gives us an I value of 0.003. So plug those numbers in over here on the left, and you can see we get a final amount or final value of her investment is $1,289.45. Okay. The second part here of the question is we need to figure out the total interest she has earned. Okay, so to solve for the total interest she has earned, if you think about it logically, her investment is worth $1,289.45, and she started with $1,200. So basically, how much more money does she have now? Well, $1,289.45 minus $1,200 tells us she has earned $89.45 in interest. Okay, if we look at the formula we used for amount, right, we use it up here as well, A equals I plus P, and you're free to use the formula as well, which is what we've done in essence. I was just thinking, if you think about it logically, her investment is worth this much at the end. At the start, it was worth this much. So the difference is obviously how much she's earned. Okay. Or you could say A equals I plus P. We need to solve for I. So this positive P gets moved to the other side, becomes negative P. So I equals A minus P, and A is $1,289.45. P is $1,200, and either way, you get to the final answer of $89.45. Okay, so quick recap there. Compound interest, so here's some more terminology. The term is the time over which a loan or investment collects interest. Maturity means a loan or investment is reaching the end of its term. A mutual fund is an investment where people combine their money to buy stocks and bonds. and share gains and losses. You won't really need to know these definitions like GIC and mutual fund, but it's just nice to know sometimes in the questions, it says you've invested in a mutual fund or a GIC. So for your own personal knowledge, just so you know what that may mean. A GIC is a guaranteed investment certificate. So that is a type of investment where the interest rate is fixed for the term of the investment. So basically you get a fixed interest rate. So it could be like a 10-year GIC. And for those 10 years, you'll get the same amount of interest. So it'll tell you at the start, okay, you can invest in this GIC. It'll get you 3% interest for 10 years. No matter what happens to the economy out there or what the government changes in terms of interest rates and things like that, or the prime rate, you will get that fixed amount no matter what for the length of the investment. RESP is a registered education savings plan, so an investment used to pay for post-secondary education. Present value is the principal that must be invested or borrowed. Okay, and the final value is the final amount of a compound interest investment. Okay, so present value, a question could be like, the investment is worth $15,000 after 5 years at, 7% interest compounded monthly. How much did you invest? How much did you have to invest at the start for it to be worth that much? So anytime you're asked for how much was invested to begin with or how much was borrowed to begin with, that's present value. Okay. The compound interest formula is set up to solve for the final value, right? A equals P times 1 plus I over N. And you can see these terms are interchangeable. Future value is the same as the amount. And then PV, which is present value, is the same as the principal, right? Which should make sense. Principal is what you start with in terms of the amount of money. And present value means the same thing. What was the value at the start of the investment or the start of the loan is the present value. Okay, so A and FV, free future value, are the same. P and PV, which is present value, are the same. And this formula can easily be rearranged to solve for the principal. Basically, if you want to isolate for P, like we've done in the previous lesson, divide both sides by 1 plus I to the N, and then there's P isolated for you. And this can also be written as A times 1 plus I to the power of negative N. So either one, these two are both the same. Use whichever one you're more comfortable with. Okay, and looking at our example here, the Singhs have a newborn grandchild. They plan to invest some money in an RESP so that he has $20,000 available for his education on his 18th birthday, assuming a growth rate of 7% per year. So that's our interest rate, compounded semi-annually, so twice a year. How much will the Singhs need to invest today? So there's your hint that you're solving for present value. How much would you have to invest today? So here's our formula. We know A, the final amount we need is 20,000. N is the number of years of the investment. So on his 18th birthday, right? So that means we have 18 years of the investment multiplied by the number of compounding periods per year. So semi-annually, it's twice per year. So 18 years for the investment times 2 compounding periods per year tells me N is 36. And then to solve for I, we take the growth rate or the interest rate, which is 0.07, and divide it by the compounding, the number of times the investment is compounded in a year, or the interest is compounded in a year, and that's semi-annually, so that's twice per year. So 0.07 divided by 2 tells me my I value is 0.035, and then we're solving for P. So at this point, plug in our A value, plug in the I value, plug in the N value, and then solve for P. And P in this case is $5,796.65. So again, what does that mean? Remember, we're trying to solve for how much will the Singhs need to invest today. So this means the Singhs must invest $5,796.65 today in order for their investment to be worth $20,000 in 18 years. Okay, so if you're asked for present value or future value, it's the same formula as the compound interest. Okay, so just remember, future value is the A value, present value is the P value. Okay, and as always, if you open the blank file, you'll see the blank practice sheet, and then the filled in file has the practice sheet with the solutions. Okay.